Let's look at the solution of this now. N is a natural number of at least 5 digits, and its leftmost digit is 6. When this 6 is removed from n, the number thus obtained is found to be 1 by 25 times of n. What is the sum of the digits of n? So n, the smallest variation of n, would be 60,000, 6 followed by 4 zeros, plus some 4-digit number x. So 1/25 of this, 60,000 plus x into 1 by 25 is equal to x itself. So if I multiply this, I will get 24x is equal to 60,000, or x is equal to 2,500, which gives me n is equal to 62500. Okay. But I cannot mark my answer as 13 straight away, 6 plus 2 plus 5. I cannot mark it as 13 straight away because this is the least case that I've taken. I'd have to check at least one more case. So let's say n was equal to 600,000, 6 lakh plus x. Again, 6 lakh plus x into 1 by 25 is equal to x, which again gets me to 24x is equal to 6 lakh, or x is equal to 25,000. So n is equal to 625,000 this time. Can you see, when it was a 5-digit number, we got 625 followed by 2 zeros. When it is a 6-digit number, we got 625 followed by 3 zeros. So even when you're increasing the number of digits, all it is increasing is a 0 at the end. Therefore, the sum of the digits will remain the same, and the answer will be 830. Next case, the digits of all the 2-digit multiples of 8 are reversed. How many of the resulting numbers would be divisible by 4 but not by 8? The best thing to do here is simply list out all the 2-digit multiples of 8. And then 32, 40, 84, 80, not 84. How have I reached 84? Sorry. 48, 56, 64, 72, 80, 88, and 96. These are all the 2-digit multiples of 8. When I reverse it, it will not be a multiple of 4. When I reverse it, it will not be a multiple of 4, not a multiple of 4. This upon reversal will give me 04, should be counted. This upon reversal will give me 84, should be counted. This will not give me a multiple of 4. This will not give me a multiple of 4. This will not give me a multiple of 4. This will give me a multiple of 4 upon reversal, but will also be a multiple of 8. So should not be counted. Should not be counted, will not give me a multiple of 4. So how many numbers? 2 such numbers. Next, if all the 2-digit natural numbers whose unit digit is greater than the 10th digit are selected, if all these numbers are written one after the other in a series, how many digits are there in the resulting number? There are 2 ways to think here. One is this way. Let's say the unit digit was 2. Then you'd have one case. If the unit digit was 3, you'd have 2 cases. If the unit digit was 4, you'd have 3 cases. If the unit digit was 5, you would have 4 cases. 1, 2, 3, 4, 5. Can you see the pattern emerging here? You can keep on going, and up until 9, the cases you would get would be 1 till 8. So basically, how many numbers? First 8 natural number sum. So 8 into 9 by 2, or there will be 36 such numbers. But the question is not asking me how many numbers are there. They're asking me how many digits are there in the resulting number if they were written one after the other. If there are 36 2-digit numbers, they will have 72 digits. One way to think is this. Another way to think is there are 92-digit numbers. From this, I'm removing all those numbers where the first digit and last digit are same. They will be 11 to 99 or 9 such numbers. So we're left with 81 2-digit numbers. Now within these 81 2-digit numbers, you would have 9 cases when it is 10 or 20 or 30 or 40. So remove 9 those cases for numbers 10 to 90. Now we are left with 72 2-digit numbers. Now 72 two-digit numbers, half of them will have, 36 of them will have unit digit greater than tens digit, and 36 of them will have tens digit greater than units digit. So this group has to be ignored. This is the group we are concerned with. How many digits here? Again, 72. You can think both ways, and it is pretty much equally efficient. Next thing, P, Q, R, S, T, U, V, W, X, Y is a 10-digit number with distinct digits such that P is greater than Q is greater than R. And S is greater than T is greater than U. And W is greater than, V is greater than, W is greater than, X is greater than Y. Okay, so let me write it down in that order. P, Q, R, S, T, U, V, W, X, Y. And the numbers are largest to smallest in that order. We were told this is a 10-digit number with distinct digits. So all 10 digits are going to get used up. S, T, U are consecutive even digits. These are even. And V, W, X, Y are consecutive odd digits. These are consecutive odd digits. If these are consecutive odd digits, then there are only two possible cases here. There are only two possible cases here. The two possible cases being 7531 and 9753, because V was supposed to be greater than W, was supposed to be greater than X, was supposed to be greater than Y. These are the only two possible cases that we can have. Okay. Next thing we are told is P plus Q plus R is equal to 9. Now see, we are supposed to use all 10 digits. STU cannot have an odd digit. So PQR is supposed to have an odd digit. Now PQR, I don't know which digit, but the odd digit that PQR will have, in the first case, it will be 9. In the second case, it will be 1. In the first case, it will be 9. In the second case, it will be 1. Can you see the first case has become unacceptable now? Because if one of the digits was 9, the other two would have to be 0 and 0. And that is not possible. So this case is entirely out of running. This is the case we are working with. Now, we need, out of PQR, 2 digits are even. STU, 3 digits are even. STU, 3 digits that are even can be 420. But then what will be left here would be 6 and 8. 1 plus 6 plus 8 is not 9. So this case is unacceptable. We will also have 6, 4, 2. What is left here is 8 and 0. 1 plus 8 plus 0. Yes, this does give me 9. So this is acceptable. Or the last case would be 8, 6, 4. In which case I'd be left with 2, 0 here. So 1 plus 2 plus 0 is not equal to 9. So this is also unacceptable. Now, given that we were told P is greater than Q is greater than R, the precise number would be 810 642 9753. What is the value of X plus Y? Answer will be option C, 8. Why we have gone ahead and made sure we have counted everything despite catching on very early that it can only be 9753 is because we also have to ensure that there is at least one such case existing. If no such cases were existing, then the answer would have been indeterminate. We have to ensure that there is at least one such case existing. Only after that we can be certain sum of X plus Y is 8. Okay, a person starts counting from his thumb. Count successively till he reaches the little finger and returns in the reverse order. For instance, if a person starts counting, he would count from the thumb numbered 1 at the end of the little end at the little finger when he has counted 5. So 1, 2, 3, 4, 5. And after counting in the reverse direction, again ends at the thumb when he has counted till 9. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So look at it. Thumb, forefinger, middle finger, ring finger, and little finger. The counting is happening 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on. can you see the number that is coming at thumb? The number that is coming at thumb is always an A10 plus 1 kind of number. A10 plus 1 kind of number. The number that is coming at the little finger is always an A10 plus 5 kind of number. But for the forefinger, middle finger, and ring finger, you don't have a unique representation. You have a unique representation when you look at it alternately, 2 and 10. Or in the next line, you would have gotten 18, 19, 20, 21, 22, 23, 24, 25. Can you see? These are all 8 and plus 2 kind of numbers. And these ones here are A10 kind of numbers. For the middle finger, you have A10 plus 3 and A10 plus 7 kind of numbers. For the ring finger, you have A10 plus 4 and A10 plus 6 kind of numbers. Okay. If the person has counted 3, 2, 2, 4, which is an 8n kind of number, 3, 2, 2, 4 is divisible by 8. On which finger would he be at the end? 8n kind of numbers ends at forefinger. So answer has to be option B, forefinger. That will be all for this episode. Hopefully you learned something. Okay, bye.